me start today's lecture by just giving one important thing, that is how to use the chain rule of derivatives. Okay, so this will be used in many occasions in case of partial differential equations. Okay, so this has been done in the last class also, but still I just want to recall it. Suppose phi is an arbitrary function. It is connected by u and v, and where u and v, these two are functions of x, y, and z. At z dependent, as usual, variable, and x and y, these are independent variable. Clear? Okay, so if we want to differentiate partially with respect to x, differentiating partially with respect to x, what we get? So this I try to just remind you that you have to recall this thing so that it will be beneficiary for many occasions. Okay, so what it will be phi of x, and not phi of x, phi of u, because u and v are two independent variable, and phi is a function which is depending on two independent variable u and v, and at the same time u and v are functions of x, y, and z. And if you go back again, then z is a dependent variable. Z is again a dependent variable of two independent variables, x and y. This is the situation. So phi u of this will be ux plus uz and zx. Clear? Because z is dependent. That is why it has to be zx. Plus phi v, we have to take both the variables, phi v, vx plus vz, this is zx, equal to 0. Similarly, again, if we want to differentiate partially with respect to y, then what we get? Phi u, this will be uy instead of ux, clear? Plus uz, this will be z, zy or zx?
ZY, sir.
ZY, sir.
Very good, zy. Next, it will be phi v, and this will be vy plus vz and zy. This will be 0. Okay, so from these two equations, we have to eliminate your arbitrary function phi, and then we have to we will arrive at a first order partial differential equation, just eliminating an arbitrary function phi. Clear? So let us start with one example so that it will be very clear to everybody, and then come back to the case when more than one arbitrary functions are there, then how we can form a partial differential equation from that. Okay, so that is the next target. Initially, one arbitrary function may be phi, which is connected by two independent variable u and v. Again, u and v are functions of x, y, z, where z is a function of x and y. Exercise 1. Find PDE by eliminating the arbitrary function phi from phi of x plus y plus z comma x square plus y square minus z square is equal to 0. Okay, so this is your question and we like to find it. Say for example, this is your equation number 1, relation 1. Okay. I assume that this is your u and this is your v. That means what we'll get, that is phi of u comma v is going to be equal to 0. This is your number 2. Clear? Where u is x plus y plus z, v is x square plus y square minus z square, and phi of u comma v equal to 0. So next we'll differentiate partially with respect to x. What we get? We will get C. What we get? This will be phi of u into 1 plus p. What is your p? Who can recall? P is zx.
Sir, ZX.
Yeah, very good. What is your q? Zy.
Sir, ZY.
Very good. So this you understand? This is phi u. If we what is it? See, phi u ux plus uz zx. What is ux? Ux is 1. What is uz? That is also 1. And zx. Zx means p. So phi u into 1 plus p plus phi v into what is vx? Who can say? It has to be equal to vx. First one. Vx is twice x.
Twice X.
Yeah. And then what is vz? Minus twice z and then zy. Sorry, zx. That is your p. This is going to be equal to 0. That means what we get? Phi u divided by phi v is going to be equal to twice z p minus twice x divided by 1 plus p. So this is your number 3. Clear? Just I divide it. By phi v is equal to, in the numerator, there will be sign change here. In this case, this is twice zp minus zp. Okay. Minus 2x divided by 1 plus p. Okay. If we differentiate again, differentiating 1 partially, it has to be 2 partially with respect to y, we get, this is again, this will be phi u, this is 1 plus q plus phi v, this
2Y
is
minus 2Z into
minus
Q.
into q. Very good. This is your 0. That means if I do it phi u by phi v, then what it will be? That is
So twice ZQ
zq
Z
minus twice y
minus twice
divided by 1 plus q. This is number 4. So from 3 and 4, what we can say? These are equal. Right and left hand sides are equal. So from 3 and 4, we can write. See in the equation. See in the equation number 3 and 4, then you see that the left hand side is phi u divided by phi v, both are same, so right hand side will be same. So if we equate these two things, then definitely we will get an equation which is free from phi. So we are done. That is twice zp minus twice x by 1 plus p is going to be equal to twice zq minus twice y divided by 1 plus q. So this is your partial differential equation. You can multiply and just do the calculation. So this is your answer. So can you say whatever the order of the partial differential equation?
Sir, 1.
One.
I have a doubt.
Order of the partial differential equation is 1. Here number of arbitrary function is what?
So number of arbitrary functions
Sir,
would be
2.
2.
No. Number of arbitrary function is 1. Phi, only phi is the
Yes, sir.
C.
Yes, sir.
Phi of u comma v. So, sorry. This is find a partial differential equation by eliminating the arbitrary function phi from this. Clear? So, only one arbitrary function is there. So, ultimately removing or eliminating that arbitrary function, we get a partial differential equation which is of order 1. Now, can you tell if a system of curves or paths are connected by more than one arbitrary functions, then what could be the order of the partial differential equation?
0.
0. Order of the partial differential equation?
No, sir, it could be 2 actually, sir. It could be more than 1 basically. It would not be 1.
Yeah, very good. So you can write one remark if the functions u and v are connected by, you can write one remark if u and v. What is u and what is v? That you know. These are functions of x, y, z, and z is dependent, x and y are independent. Okay. If these are connected by more than one arbitrary functions, that is phi1 u comma v plus phi2 u comma v up to phi n u comma v, this is going to be equal to 0, where n is strictly greater than 1, that means more than 1, then the PDE obtained eliminating the arbitrary functions phi1, phi2 up to phi n is of order greater than 1. Okay, so this is important, greater than 1, and this is also important. Clear? Okay, so I like to give one example here how to do that, how to eliminate that. So, example, find a PD by eliminating the arbitrary functions phi from this. Z is equal to f of y plus ax plus g of y plus bx, a not equal to b. If a equal to b, then it is easy. Okay, so this is your question solution. So you understand where these two things are arbitrary functions. And what is about a and b? Who can say?
Sir, arbitrary constants.
No, this is
No,
just
sorry,
a
sorry, sorry.
constant. These are not equal. Okay, so arbitrary functions f and g. That means f could be anything. You can take any functions of y plus ax. Okay, similarly g is any functions, arbitrary function. That's the meaning. Okay, since these functions are arbitrary f and g, so you can get a class of surfaces or class of functions. Understand? So from our system of curves you will get, and from that system we have to find a partial differential equations. We have to eliminate here f and g only. Clear? Okay, so how it can be done? Definitely in this case, as from the just remark, if you see, and the order of the partial differential equation will be more than one. But naturally, if you try to see that, if whether it is possible to find a partial differential equation by eliminating f and g whose order is 1, but it is not possible. Definitely we have to go for higher derivative. So what we will try? We will try to find the second derivative, mixed partial derivative, and zxx, zyy like that. Yeah. So we do, okay, don't write, just I do the main thing. So if I do zx, then it will be a f dash y plus ax. Clear? This is, I just differentiate partially both sides with respect to x. Since f is arbitrary function, we do not know what is its derivative, so we write it f dash x, f dash y plus ax, and y plus ax, its derivative with respect to x partially, it is a. Clear? Clear or not?
Yes, sir.
Yes,
Okay.
sir.
Then it will be b of g dash y plus bx. Okay, so this is your maybe this is your equation 1, this is your equation 2. Next, zy, what it will be? This is simply f dash y plus ax plus here also g dash y plus bx. This is your number 3. Okay. What is zxx? If I, what happens?
Sir, f
Rajata,
double dash. Sir, f double dash y plus ax.
it will be a
A
square.
square, sir.
A square. A
F
square
double
f
dash.
dash. Yes, sir.
Yeah. Please mute. Then it will be b square g double dash y plus bx. Okay, so this is your 4. Okay. Now what will be zx, zyx? This is a f double dash plus b g double dash. Clear? This is 5. I do not write the inner one. Okay. So this is same as basically z xy. Mixed partial derivatives are same. Next, if we do that z yy, what it will be? See the equation, this one, y again. So there is no coefficient of y, so it will be f double dash plus g double dash. There is no other thing. This is 6. Clear? So we can multiply AB in equation. Multiply 5 by AB and adding with 2, we get it. We get what we get? This is ZXX plus ABZYY. This will be A into A plus B, F double dash plus B into A plus B, G double dash. This is your
Sir, but 5 is ZYX, sir.
5 is ZYX and ZXY, these are same.
Yes, sir,
Okay.
but you said you are multiplying equation 5 by AB. So in that case, it will be ZYX
Okay.
into AB.
No. That is equation 6, it will be.
Okay.
Adding with 2, it will be adding with 4.
Hello, sir.
Yes.
Yes, sir, that will be adding with
Sir,
4.
I
Yes, so adding with 4 it will be.
Yes, adding with 4. Ultimately, ZXX plus ABZYY, this is your this. Okay. This is your 7. Next, whatever we can write, ZXX plus ABZYY minus A plus B into ZXY. So what it will be? Okay, I can make it more easier here. I can make A plus B common, so that it will be A F double dash plus B G double dash. What is A F double dash plus B G double dash? This is your ZXY
5. ZXY.
from 5. From 5. So this will be your 0. Clear? So we are getting it.
Sir, I have a doubt regarding this.
Okay, where is the doubt?
Sir, analyze the equation number 2 and equation number 3 in the.
Yeah,
Yes, sir.
equation number 2 and 3.
Yes, sir. In equation number 2, we assume that there are two variable f dash and g dash in the equation, and two equation are there and two variable is there. Therefore, we can solve this. Can we do like that?
Oh, from equation 2 and 3, you want to say f dash and g dash, these are two variables, and
And two equation.
two equations.
So can we solve like that?
But it has to be independent. We have to see, means A into
Just multiply the second
C,
equation by a and subtract from above, like that.
A minus B has to be, if it is 0, then these are dependent. If it is non-zero, then you can do actually. But in that case, what I see, this is something like A capital X plus B capital Y is equal to something, some P. P
Yes,
is
sir.
ZX, and this is only
X
capital
plus
X.
Y.
capital Y
is equal to
this
Q.
is equal to Q. From here you want to eliminate your
So for the X and Y.
X and Y.
Yes,
Okay, so
sir.
here in order to have unique
Okay.
solution, okay, let me try to understand. In order to have unique solution, this determinant has to be equal to your non-zero, is not it? If it is zero, now
Yes.
if it is zero, then it will be dependent.
What about
Clear?
Zx and Zy? What about Zx and Zy? They are constants.
No, no, no.
Means Zx and Zy. The answer will be in terms of Zx and Zy then.
Yes, yes.
Okay.
Yes. The PD will be in ZX and ZY. That will be fine.
That will be fine because you cannot eliminate ZX and ZY. ZX and ZY will be there.
Yes.
Okay.
Yes, that will exist in the solution.
What is the determinant of this coefficient matrix? That is A minus B. Clear? So
Yes.
by the given condition, A minus B is non-zero. So that means this is your linearly independent. So you can find the solution by Cramer's rule. So you can find basically f dash x and g dash x in terms of p and q and a and b possibly. Clear?
Yes. Yes.
Again,
Yes, sir.
but you have to put the values for f dash x and g dash x in the given equation. Okay.
Yeah. Simply like that, we can find the value of X in
No,
the
no.
form of PQAB and Y also in the form of PQAB.
If you do like this, if you multiply here a, then if you eliminate, then you can find y in terms of this. Okay, f dash x and g dash x you can find by means of p and q. And
process.
clear.
Yes, sir. Yes, sir. In the term of
But
yes, sir, in term of
ultimately
P
you
and
have
Q.
ultimately you have to use this equation, na? But in this equation it involves only f and g, but not its derivative. Then you cannot find the solution. Somehow, what is your aim? Somehow we have to find a relation involving the derivatives or maybe possibly with constants and dependent independent variables without having f and g. But your purposes are not solved here. Understand? You can solve for x and y. The x is basically f
No,
dash
sir.
x.
We can. Sir. Sir. Hello.
Yes, tell me.
Sir, after solving the f dash and g dash in the term of zx, zy, and a and b, we will put the value in the equation number 2 or 3 in any one.
Then that you will get an identity. That is not an equation. Okay. Say for example, x minus y equal to 0, and say another x plus y. This is minus 1. Okay, equal to say for example 1. So in this case, whatever you will get x and y, if you put it here again, then that is an identity. That is not an equation.
Okay, sir. Yes, sir. That will
Understand?
be identity. Yes, sir. Yes, sir.
That will be an
Yes, sir. That
identity.
will
So
be identity because we are putting the value of f.
from where you get, and if you put it there, then it becomes an identity. See, for suppose this is a system of linear equations, and this is solvable. Clear? And if you find x and y from here, and if you put that values here, then you will get an identity. So definitely your purposes are not fulfilled. Okay. So question is good.
Oh, okay.
Okay. So can I skip now this thing? Hello. Hello.
Yes, sir. Understood, sir.
Yes. Okay. Very good. Can you tell your name? Who is asking this question? What is your name? Who asked that question? Please tell.
Sir, Sangam.
Sangam, okay. Okay, so whenever some system of equations is connected by more than one arbitrary function, then definitely we have to go for the second order or higher, means higher order partial differentiation, and ultimate differential equation will be of order greater than 1. And as I told you in the beginning of that second exercise, that the whatever the partial differential equation will get, that is of that may contains constants, because a and b are constant, not arbitrary constants. Okay, here arbitrary functions are small f and small g. We have to eliminate only those two arbitrary functions. Okay, today number of student is very less. Why? Okay, Shankita, when is your second sessional?
Sir,
CA2?
24th onwards.
24th onwards. Okay.
So that means they are calling it mid-sem. It is not continuous assessment. It is written as mid-sem.
It is written as mid-sem? No.
Yes, sir. It's
Let
written
me
as
check.
mid-sem.
Sir, it is of 25 marks, sir. So it is like mid-sem only.
Yeah,
No.
because last time I thought that the 15 marks were continuous assessments.
No. That is a CS2, continuous assessment 2. Only one examination will be there. Okay, I am checking from.
Yes, it is continuous assessment too. Yes, it is, but the marks
Yes.
is 25.
That I know.
Yes, sir.
Okay,
That
so
is
what we decided, we will conduct via quiz. Okay, whatever we conducted earlier, and that will be your particularly of 25 marks. Maybe from my part, a little bit more marks, because I am taking 2 classes, and Professor Kaur's part it will be little bit lesser marks. We have not yet decided what, but my syllabus I can tell you. My syllabus is just whole complex analysis. Or should I just omit the portions whichever it is covered in CA1? What is your suggestion?
So include the
Omit
second
CA1,
part
sir.
only, because we will get more time to revise these parts. I mean, more precisely. I think the second part only will be a better option.
That I can allow, but you have to keep in mind that your final end semester examination, that will be an end semester examination of 60 marks as per the academic calendar. So that is definitely from the whole syllabus.
Okay, sir.
Okay, so I can omit the first parts, whatever it is covered. In that case, can I include the formation of partial differential equations, one questions, because that is very easy. So today formation of partial differential equation will be over, and still I will get one more class to cover some other parts. Okay, so formation of partial differential equation, this part is included. Clear? So you can make a note. Complex analysis,
Sir.
the parts. Which? Sangam?
Yes, sir. Sir, power series will be included or omitted?
Power series included.
Included. Okay, sir.
Okay. And from partial differential equation, formation of partial differential equation, this is there. Okay. And please talk to Professor Kaur regarding his part. Clear?
Sure, will this one also be MCQ type?
Yes. More this one will be MCQ type, but this time you may have to solve some questions in order to get the answers. Understand what I mean? Suppose some complex integration is there, you have to solve it in your, you have to solve and then you have to find the answer. Okay.
And
Okay,
number of
next.
Then
questions.
then sir, allot the prop time.
Who is saying this? Definitely I will do that. This is my part. Okay. Next, solution of first order PD. Okay. So that is the second chapter. Now, before coming to the solution of a partial differential equations, as you know, in case of ordinary differential equation also, what do you mean by a solution? Can anyone tell me? Solution of a partial differential equation. Okay, let me tell. Please tell.
Finding the original function f from the given partial equation.
No.
Integrating partially.
What do you mean by a solution of a partial differential equation? That is my question.
Sir, basically, sir, the original function, sir, like the values of
So
z
the equation
or
that
for
will
that
One
matter
involve
u.
component
only
of the
the
original function
first
plus
order
some
derivatives
function of
of
t.
the.
Okay, Prajata, you want to say something?
Yes, sir. Basically, u or z. Basically, the expression of u or z.
Okay, mute yourself. Any other? Anurag Mondal?
Sir, I was saying like we'll get like one component of the original equation. So it will be like if we solve it with respect
I do not understand. A partial differential equation is there. What do you mean by original? Several times original term is coming.
with then the equation will have multiple variables, right? So it will have a variable of x, y, z. We can group them all into like individual component wise. So if we integrate with respect to solve with respect to any one variable, then we'll get that component and the rest will be like a, so in case of normal integration, if we get a like the plus c, here it will not only be plus c but also a function of the other
Okay,
variable.
you try to describe the method, what it will be. Okay, anyway. Any other? Shankita, you want to tell something? No.
Sir,
Okay, let me tell.
sir, if we are
Yes, sir. I was
given
saying
a
that it.
partial differential equation of the
Orko,
function f,
Orko,
yes, sir. Sir, if we are
okay,
given
please,
the partial
please
differential,
wait.
okay, sir.
Orko,
Okay, sir.
please wait. Okay, Shankita.
Sir, I was saying that it will involve only the first derivatives of the unknown function.
Okay, no. Orko, now your turn.
Sir, if we are given a partial differential equation of the function f, uh, then f equal to 0 is the solution of that partial differential equation.
Okay, no. Okay, let me tell. Then I think most of you definitely know what what you mean by solution, but it is difficult for you to tell in terms of the definition. Or informally, I like to say a relation between the variables which does not contain any derivatives and which identically satisfies a given partial differential equation is called a solution, or sometimes its name is integral of the partial differential equation. Should I repeat it?
Yes, sir. Please do, sir. I can't really catch you, sir.
Okay. A relation between the variables. You see, that means a relation which contains only the variables, which does not contain at the same time, which does not, that means the relation does not contain any derivatives, so it will be free from derivatives. Here in this case definitely partial derivatives, there will be no partial derivatives or any derivatives, and which identically, which means the relation identically satisfies a given partial differential equation, is called a solution, or it has another name, integral of the partial differential equation. Understand? So we have to find a relation that involves the variables, and definitely that relation should not contain any derivatives, and which identically satisfies that partial differential equation, whatever we are going to find a solution. Okay, so that is regarded as the solution of the partial differential equation, or sometimes we can say integral of the partial differential equation. So your time is already up. So in the next class, we will focus on Lagrange's method for solution of first order quasi-linear partial differential equation, that is PP plus QQ is equal to R. This is a Lagrange's
Sir, when will we get the notes for PD, sir?
oh, okay, by tomorrow.
Okay, sir. Thank you, sir.
Okay, it is almost ready. I am just checking it for 1 second. Okay, so here P, Q, and R, these are functions of x, y, and z, small x, y, and z. So this type of first order partial differential equation is not a linear partial differential equation. I told in the first class, this is a quasi-linear, and this is known as the Lagrange's form of partial differential equation, quasi-linear, and the solution is suggested by Lagrange himself. So that is what we have to learn first. That is known as the Lagrange's method for solution of the first order quasi-linear partial differential equation. Okay, so that will be started in the next lecture. Here, so this much for today.